In this problem, a bullet is fired into a block of ballistics gel at a speed of 400 meters per second. It stops 2.5 meters into the block, and we know that the bullet has a mass of 0.01 kilograms. We want to know what's the resistive force acting on the bullet, or rather the force of friction going against the bullet while it's going into the block. So I basically drew my picture. I've got my bullet here. It's going to go into the block there. I have my numbers. My initial speed is 400 meters per second, 2.5 meters into the block. The mass is given, and I know I'm trying to find friction. We always want to start with our conservation of energy equation, which is right here in purple. And now we can start canceling out anything that doesn't belong. So initially, does the bullet have potential energy due to gravity or a spring? You could say that it's above the ground, but when it gets into the bullet, or the bullet gets into the block, it's not going any lower. So we're going to say no gravitational potential energy. We can cross that off. Does it have kinetic energy? Absolutely, because it is moving 400 meters per second. When it gets into the block, does it have potential energy here? No, it didn't gain any gravitational energy, and there's no springs or anything. Does it have kinetic energy? No, because it's not moving. So all the energy was taken away by friction. Now I'm going to write down my equation for kinetic energy on the left side and thermal energy on the right, and that's what we're going to work with. So kinetic energy is 1/2 mv squared, and thermal energy is the work done by friction, which is force times cosine theta distance, but there's no angle. So I don't have to worry about the cosine theta part, so I'm going to leave it off, and I just have friction multiplied by the distance the bullet traveled into the block, which is how much distance the friction was acting on the bullet. Now we're trying to solve for force of friction. To solve for that is really easy. I just divide my d, or distance, over to the left, giving me the equation 1/2 mv squared divided by d equals the force of friction. Now I can plug in my number because I have them all. And that's 1/2 times 0.01 kilograms times the initial speed, which was 400 meters per second. We have to square that, all over a distance of 2.5 meters into the block. And that'll give you my force of friction, which should be 320